The objective of this lecture video is to form composite functions and determine their domains. The composition of a function f with g is denoted by f after g and is defined by the following equation. F after g is the same thing as f of g of x, which means that the function g is going to act as an input element to the function f. If this is the definition of the composition of the function f with g, then the domain of the composite function, which is the one resulted by this operation, is the set of all x such that x is in the domain of g, and that g of x is in the domain of f. The following values must be excluded from the input x. If x is not in the domain of g, it must not be in the domain of f after g, or the composition of the function g. Then any x for which g of x is not in the domain of f must not be in the domain of the composite function. Let's take an example. Let's assume f of x is equal to 4x over x plus 2, and that g of x is equal to 1 over x. I wanna generate the resulted function by performing the composition of the function f with g. The interpretation of this notation that it is equivalent to f of g of x, where g of x is defined as 1 of x. Notice here that the function f of g of x is becoming the input into the function f. If we look at the definition of the function f of x, it is 4 divided by the quantity of x plus 2. Notice here I replace the value of x with my input value, which is g of x, 1 over x plus 2. So basically, what needs to be done is wherever your input variable is to replace it with the input value. In this case, it happens to be a function. As a result of that, I end up with the result of 4x over 1 plus 2x. In order to get this one, you may like to come up with the common denominator between x and 1 and perform some algebra in order to generate what you have here. The domain of the resulted function which you have here should be, since the resulted function is a rational function where the ratio sign is apparent here, I need to set the denominator to be equal to 0. When solving that, you'll end up with x equal to negative 1/2. As you can see here, I'm excluding the negative 1/2. However, some of you will be wondering, so why we are excluding the 0? Keep in mind that x is in the domain of g, and if x is not in the domain of g, it must not be in the domain of f, the composition of the function f with g. Well, let's look at the function g of x. If we look at it, it's a rational function. There is a ratio sign, and we need to avoid the use of 0. And therefore, we are excluding 0 as a value that is associated with the domain of g of x. And therefore, this resulted also in removing the 0, according to the condition that we have here in A. X is in the domain of g. However, 0 is not in the domain of g. Since 0 is not in the domain of g, therefore we don't include it here. Let's take an example here, where we have the function f of x defined as 5x plus 6, and another function g of x defined as 2x squared minus x minus 1, and we are to find the composition of the function f with g, which is equivalent to f of g of x. Notice here that I have the definition of the function f of x as 5 times x, but x here in this case is g of x plus 6, and the definition of g of x is 2x squared minus x minus 1. Therefore, multiplying 5 or distributing over each term that you find here, you end up with 10x squared minus 5x minus 5, because 5 times 2x squared, 5 times negative x, and 5 times negative 1. Trying to simplify the result here, you end up with 10x squared minus 5x plus 1. If we are looking at the composition of G with F, then F becomes my input. In this case, I will go back to the definition of G. 2, which is what you see here. However, I have to replace the x with f of x, and I have to square it, minus, and that's what you see here. And then x, remember again, your f of x is the input value, minus 1. I need to go back to the definition of f of x, which is 5x plus 6. Therefore, I'm going to replace f of x wherever it is with that value. Here you have to foil first the 5x plus 6, meaning that you have to multiply the 5x by 5x to end up with 25x squared. The 6 times 6, which will give you a 36. Then multiply the 5x by the 6 to give you 30x. Multiply that by 2 to give you a 60x. Minus 5x minus 6 minus 1. The end result, as you start to simplify all of that, you end up with this function here. Therefore, what is the composition of the function f with g given the input value of negative 1? This is the same thing as I need to go back to the result that I have here. After all, the composition of the function f with g is given by this rule. So I need to replace x with negative 1. That's what you see here. And then try to simplify the expression that I have. I end up with 16. Please feel free to pause the lecture video at this time and take your time to go over the various steps for solving each one of those expressions, and feel free to contact me if you still have some questions. Now it's your turn. Have your pencil, paper, and your eraser ready. And given f of x equal to 4x minus 3 and g of x is equal to 5x squared minus 2, you are asked to find the composition of the function f with g, the composition of g with f, and then find the composition of f with g given an input value of 2. Please pause the lecture video at this time in order to solve each one of those problems. These are the suggested solutions. I hope that you are successful in coming up with the same solutions that I have here. At this time, I will ask you to pause the lecture video and compare the proposed answers with the answers that you came up with. And if there are any errors that you see or you need further explanation about what I've done in order to come up with those answers, please don't hesitate to contact me.